Today we're going to look at the characteristics of the graph of a logarithm. So over here on the right, and you don't have to put this in your notes, I just want you to see this. Over here on the right, this is an exponential growth function. This is what we learned about in our last chapter. We learned in our last video that logarithms are the inverse of exponential functions. So if this is an exponential function, an inverse is when you switch x and y. So it flips it over this diagonal line. So the graph of the log ends up looking like this. With an exponential graph, we have an asymptote at the x-axis. The x-axis is an asymptote that graph will not cross. Well, if you switch that, instead of on the x-axis, for a log graph, the asymptote is going to be vertical and it's going to be on the y-axis. So now our asymptote is vertical, and vertical lines have the equation x equals. So in this first one, y equals log base 2 of x. This is just a simple log graph that hasn't been moved around, hasn't been messed with. It has an asymptote at 0. And because that is a vertical asymptote, the asymptote is x equals 0. And because the asymptote is an x equation, the asymptote is going to be tied to the domain because the domain is also the x values. Notice all of these points are on the right side of that asymptote. So this domain is x is greater than 0. This point is like 0.2. This point is 0.5, 1, 2. Somewhere over here there's like, let's see, this one is 4. All of those x values are bigger than 0. So all of your x's, your domain x is greater than 0. Our range this time is all real numbers. Do you see how that switches from exponential graphs? With exponential graphs, we had the asymptote was y equals 0, the domain was all real numbers, and the range was y is greater than whatever the asymptote was. We've kind of switched that around. Now the asymptote is x equals, the domain is tied to the asymptote, so x is greater than 0, and the range is all real numbers. So pretty much for all of these, you could go through right now and fill in that the range is all real numbers. The range for log graphs will always be all real numbers. This one, the asymptote has moved over here. What in the world would cause the asymptote to move left 2? Notice right here, plus 2 means left 2. So just like before, anything that's with the x is going to shift this graph side to side, and it's going to be opposite. So now the asymptote is x equals -2 because it shifted left 2. Your domain is going to be x is greater than -2. So if plus 2 moved it left 2, this -2 over here is going to move it right 2. And here is the asymptote at x equals 2. So our domain is x is greater than 2. Your asymptote and your domain are going to be tied together. Okay, this is another just basic log graph, but instead of being log base 2 of x, it's log base 3 of x. It just looks a little bit different, but notice it still has an asymptote of x equals 0. The range or the domain is x is greater than 0, and your range is all real numbers. Okay, in this graph, I kind of want you to focus on this point right here. In this next one, that point has moved there. So the point was here, and it moved down 2. Notice the -2 after the parentheses, that moved this graph down 2. Now, here's the thing that I really want you to see. Because we moved the graph straight down, and that asymptote is vertical, it didn't change the asymptote. Our asymptote is still x equals 0. Our domain is still x is greater than 0. our range is all real numbers. Here, that point, which was originally here, moved up 2. That plus 2 tells you up 2. So our asymptote hasn't moved because it's a vertical movement. Vertical movement's not going to change the location of a vertical line. Our domain is x is greater than 0, and our range is all real numbers. Here again is y equals log base 2 of x. We can just fill this in really quick. What happens if there's a negative inside with the x? If there's a negative inside with the x, that is going to be a horizontal flip. Anything that happens inside the parentheses is going to be a horizontal change. It's either going to move it left or right horizontally, or it's going to flip it horizontally. So this graph was originally over here, and it flipped it over the y-axis. Now here's what I want you to notice. It didn't change where the asymptote is. The asymptote is still x equals 0. But this time, the graph is on the left side of the asymptote. So now the domain is x is less than 0. The domain flipped because the graph flipped over the y-axis. Your range is still all real numbers. In fact, your range is always going to be all real numbers. The negative in front is a vertical flip. So instead of the graph looking like this, it flips around and that it's approaching the asymptote up instead of down. This asymptote is still at 0. The domain, because the graph is on the right side of that asymptote, x is greater than 0. Ta-da! Some of you have graphing calculators, so I want to show you how to graph these on a graphing calculator, but then I'm also going to show you all how to use a site called Desmos, because Desmos will work on any browser no matter where you are, even if you don't have this calculator. So if you have this calculator, watch this portion. To graph a log function, of course we have to go into y equals first, clear out anything that's in there, make sure your plots along the top are off, all of that good stuff. To type in log base 3, you're going to push alpha window, and this thing will pop up, and option number 5 is log base. So you click number 5, and then it gives you this like template to fill out. So we want the log base 3 of x plus 4. Close your parentheses, or your parentheses are there, so just move outside of your parentheses. And then plus 2. The first time you graph, I want you to do zoom 6 just to reset your graph in case things have changed. Honestly, you should be able to fill out the asymptote, domain, and range just from looking at your graph. This plus 4 means that the graph is going to shift left 4. So the asymptote is going to be at -4. And of course, I gave you a graph on this paper that doesn't fit that because I'm awesome like that. So -4 would be over here. That means our asymptote would be here. My bad for giving you a terrible graph in your notes. I know I'm cool. I'm awesome like that. This graph is also going to move up 2, but that doesn't affect the domain or the range. The domain is tied to the asymptote. I don't see any negatives in here, and when I look at this graph, it's on the right side of the asymptote. So x is greater than -4. And then the hardest part, your range, all real numbers. To get the points, you do second graph. That takes you to your table. And you can just pick out a couple of points. Remember, you can go up or down. Notice at -4, it says error because you can't go past, you can't do -4 and you can't go past -4. So I would probably use -3, 2, get the closest one to that error. Then maybe -1, 3, and oh, I don't know, I like that 5, 4. Pick the ones that are nice and easy. You don't have to do the decimals if you don't have to. So -3, 2, -1, 3, and 1, 2, 3, 4, 5, 1, 2, 3, 4. And then you can kind of look, it's going to touch or get really close to that asymptote, but not actually touch it, and then curve out. And it looks like it kind of flattens out, but it does keep on going to the right. Now, how would you do this if you don't have a graphing calculator? Pull up a browser. I'm going to try to fit this in here a little bit. We are going to go to www.desmos.com. That's all S's. DESMOS.com. DESMOS.com. This is an online graphing calculator, and you click Start Graphing, and it pulls up this awesome looking graph. Over here on the left, this is where you're going to type in what you want to graph. Let's do that same number 10. We want log base 3, and you have to do y equals first. The y equals isn't there, so you have to type in y equals, type in log. Then I want you to push shift and your dash button. That's like underscore. It's the button right next to the 0, between the 0 and the plus equals on the top of your keyboard. It's the dash and the underscore. So if you do shift and then that button, that does underscore, and that pops this down into subscript. You can type in that 3 to get that base 3, and then your right arrow, parentheses, x plus 4, close your parentheses, plus 2. Oops. And it graphs it. Now this is great, but we need some points. How do we get some points? So click on this little settings wheel, and then this table is an option. So you can click that button and look at that table. And it shows a few points. It shows basically the point. It doesn't show as many points, which kind of stinks. I think let's try, if we wanted to type in 4, yep. Type in 5 and it shows you. So if you want to keep going, you can type in any number. We could also type in like -3 and it would tell us that point. So you might have to kind of experiment with those points a little bit, kind of look at your graph and say, I think I want this point right here. And you can kind of see. But when you do have those points in the table, notice it also marks those points on the graph. Okay, so again, that was the little settings wheel. And oh, I clicked out the whole graph. Hold on, I want to undo that. Okay, and see there's a little undo redo, which is kind of nice. You can go back to, can I go back? I don't think I can. Okay, now the next one you want to graph, you would do y equals in the next line, or you could just X this out and then you could keep going. So what I want you to do is I want you to try number 11 on your own. So pause this video, and try this problem number 11 on your own, either using your graphing calculator or Desmos. See if you can do number 11. Then play the video and check. Pause the video, pause the video, pause it, pause it, pause it. To type it into a graphing calculator, -2, make sure you use the negative button, not minus. Alpha window number 5 gets you that log base 2 of x minus 1. Oops, we don't want an extra set of parentheses. And then -5. You can look at it and then go into your table, pick out some points. On Desmos.com, you would type in y equals -2 log shift dash, that gets you your base 2, get out of that base of x minus 1, close your parentheses, -5. Then to actually see the table, you'd click Edit List and go into the table. Now, a lot of these points are not very good. I think I want, I don't know, I definitely want -5, 2. So I'm going to type in -5, or sorry, that's 2. 2, then maybe 3, 4, 5, 6. Type in some points that might be more advantageous and then grab those. Stinks too, so feel free to move where your axes are to fit it better. Plot some of those points. Don't forget about your domain and your range. Your asymptote is 1.